Howdy, this site-specific standard operating procedure details surface water sampling procedures performed at Carter's Creek, which is adjacent to Texas A&M's golf course. Water testing and analysis is to be conducted at a later date to determine whether the concentration of contaminants such as fecal coliform bacteria, phosphates, nitrates, and chlorine are present at risk to public and ecosystem health. The following is equipment necessary for water sample collection: a baler to collect the background sample, a dipper, glass containers with screw caps lined with Teflon, a cooler and ice pack to transport and preserve samples, a DO bottle, a meter that measures electrical conductivity, salinity, and total dissolved solids. The one shown is an X-Stick 2, and handheld pH meter, sample labels, custody seals, and chain of custody form, as well as a writing utensil, safety equipment, which includes gloves, goggles, safety vests. This personal protection equipment must be worn at all times during sample collection. A deionized water bottle and paper towels, which will be used to decontaminate equipment, a tape measure, stakes, and GPS to mark and record where sampling will occur.
Before actual sampling occurs, the sampling site should be prepared. The sampling of these surface waters will be based on a systematic sampling approach. First, all proper sampling equipment should be cleaned. Then the starting point was determined randomly. We began at GPS coordinates north 30 degrees 36.870 and west 96 degrees 19.953. At this point, we placed a stake parallel to the river, and then using a tape measure, a new stake is placed in 3 more locations in 5-foot increments moving upstream from the original stake. The location for the background sample should also be chosen as far away from the primary sampling location as possible.
This section of the standard operating procedure covers sampling procedures using both dipper and baler to take surface water samples. Samples will be collected from the center of the stream at the stream surface so as to ensure that no stream sediment is disturbed or collected. The first sample will be taken at the furthermost downstream location. Each subsequent sample will be taken upstream from the initial location at each of the previously marked intervals for this site. 6 samples will be taken using the dipper. These samples will include 4 systematically collected samples, 1 co-located sample, 1 rinsate sample, and 1 dissolved oxygen sample. The dissolved oxygen sample will be collected in a DO bottle, while the rest of the samples will be collected in glass jars.
After collecting the water sample with the dipper, a background sample is required for quality assurance purposes. Due to the limitation of the elevation near the stormwater drainage location, a baler was used to collect the background sample. Use the rope to tie a nut on the top of the baler to lower it into the water body. Remove the mouthpiece at the end of the baler to properly collect the water sample. Be careful when lowering it down and do not disturb the sediments at the base of the water. After collecting the water, raise it back up. Place the mouthpiece at the end of the baler to release water into the glass container. Any excess amount of water redistribute back into the creek. All samples with the exception of the DO sample will be tested at the time of collection using a pH meter to measure pH, total dissolved solids, salinity, and electroconductivity. Were also measured using an X-Stick 2 meter. After field testing, all samples were stored in an ice chest at 4 degrees Celsius for further lab testing.
Additional testing of the samples will be performed in the laboratory. These tests include the following. The test for the presence of fecal coliform bacteria in samples will be observed by inoculation of eosin methylene blue or EMB agar plates. Dissolved oxygen content will be measured using Chemet's dissolved oxygen kit. The concentrations of chlorine, nitrate, and phosphate contained within each sample will be measured individually using the appropriate HANA photospectrometry equipment and the respective procedures and reagents.